The first anomaly reports entered the Bluetooth Special Interest Group's incident monitoring system at 0647 Pacific Time on Friday, March 14, 2025, originating from automated telemetry collectors distributed across Santa Clara County, California. Network administrators at 17 separate corporate campuses logged identical symptoms within an 8-minute window. Peripheral devices, including wireless earbuds, portable speakers, fitness trackers, and automotive infotainment systems, were initiating pairing sequences without user authentication requests, bypassing the standard secure simple pairing protocol that had governed Bluetooth device relationships since the 2.1 plus EDR specification in 2007. The affected devices were not requesting PIN codes, not displaying pairing confirmation dialogues, and not respecting previously established trust relationships stored in their non-volatile memory. Instead, they were executing what protocol engineers would later term opportunistic association, automatically connecting to whichever compatible device presented the strongest received signal indicator within their approximate 10-meter range, regardless of prior pairing history or user preference settings. This represented a fundamental violation of the authentication layer defined in the Bluetooth core specification, specifically the security mode requirements that mandate mutual entity authentication before link-level encryption can be established. The initial incident tickets were filed under routine troubleshooting categories, tagged with identifiers suggesting interference from new wireless deployments or misconfigured access points, because the behavior pattern did not match any known vulnerability class or previously documented protocol failure mode in the 18-year operational history of widespread Bluetooth implementation. Between 0715 and 0830, as morning commute patterns brought hundreds of thousands of active Bluetooth radios into proximity across the Highway 101 corridor, from San Jose through Mountain View to Palo Alto, the 2.4 GHz ISM band experienced what spectrum analyzers would record as a 340% increase in adaptive frequency hopping collisions compared to baseline measurements from the previous 30 days. Bluetooth devices operate by rapidly switching between 79 different 1 MHz wide channels within the 2.400 to 2.4835 GHz range, using pseudo-random hopping sequences to minimize interference. But this mechanism depends on devices maintaining distinct PicoNet identifiers and coordinating their channel usage through timing synchronization. The widespread pairing dysfunction eliminated these coordination boundaries, causing devices to form overlapping PicoNets, where a single master device might simultaneously maintain active connections to 15 or 20 slave devices, rather than the typical maximum of 7 defined in the scatternet topology specifications. Parking structures at Apple Park, Google's Bayshore campus, and the Stanford Research Park became unintentional amplification zones where the density of Bluetooth-enabled devices exceeded 200 active radios per 100 square meters, creating what RF engineers term a spectral saturation condition, where the probability of successful packet transmission dropped below 40%, even for devices in direct line-of-sight proximity. Automotive systems presented particularly complex failure patterns because modern vehicles contain between 15 and 45 separate Bluetooth modules, controlling functions from hands-free calling to tire pressure monitoring. And these systems began forming connections with pedestrian smartphones through car windows, playing notification sounds through vehicle speaker systems, and displaying incoming message previews on dashboard screens for users who had never authorized those pairings. The technical mechanism underlying the dysfunction became partially visible through examination of packet capture data from wireless monitoring equipment operated by Santa Clara University's Network Engineering Department, which maintained a research installation specifically configured to log Bluetooth low-energy advertisement frames across the campus area. Analysis of these captures revealed that affected devices were broadcasting pairing availability announcements at intervals of 20 to 40 milliseconds, rather than the standard 100 to 1000 millisecond range, creating a 10 to 50-fold increase in discovery traffic that overwhelmed the capacity of receiving devices to properly evaluate and filter connection requests. More significantly, the security flags embedded in these advertisement packets showed incorrect bit patterns in the authentication requirements field, specifically setting both the MITM protection not required and bonding not required flags simultaneously, a combination that effectively disabled the cryptographic validation steps that normally prevent unauthorized pairing. This configuration allowed devices to complete the pairing handshake using only the simplified pairing algorithm specified for legacy compatibility scenarios, bypassing the elliptic curve Diffie-Hellman key exchange that generates the encryption keys protecting subsequent data transmission. The packet captures also documented that devices were not properly implementing the disconnect command defined in the host controller interface specification. When users attempted to manually sever connections through their device settings menus, the devices would transmit the appropriate disconnect packets, but then immediately reinitiate the discovery and pairing sequence, often reconnecting to the same device within 2 to 5 seconds, and sometimes forming multiple simultaneous connections to different interfaces on the same host device. Public manifestations of the protocol failure became widespread between 9 and 11 as office workers arrived at their workstations and the density of active devices reached typical weekday operational levels throughout the commercial districts of Sunnyvale, Cupertino, and Menlo Park. Conference rooms equipped with Bluetooth-enabled presentation systems began displaying content from laptop computers in adjacent rooms or on different floors, determined solely by signal propagation characteristics through building materials rather than intended user selection, creating situations where confidential product development presentations appeared on screens during unrelated meetings. Wireless speaker systems in open-plan offices, normally used for background music controlled by designated administrative devices, began playing audio from whichever smartphone within range had most recently generated a media output event, producing an overlapping cacophony of podcast playback, video soundtracks, and notification tones that rendered affected spaces unusable for normal work activities. Fitness tracking devices worn by employees recorded heart rate, step count, and GPS location data to cloud synchronization services through whichever connected smartphone provided an active data path, rather than the devices owned by the users wearing those trackers, resulting in cross-contamination of personal health data across user accounts that would require extensive database reconciliation procedures to correct. The lack of pairing authentication also meant that these connections were established without the notification prompts that would typically alert users to unexpected device relationships, so many affected individuals remained unaware that their devices were broadcasting or receiving data through unauthorized channels until they physically observed their screens displaying unfamiliar content or their speakers outputting unexpected audio. Technical response teams at major technology companies implemented initial containment measures between 1130 and 1300, though these efforts revealed fundamental limitations in the available remediation options given the distributed nature of Bluetooth device implementation and the impossibility of centralized control over consumer electronics. Network security groups issued guidance recommending complete disablement of Bluetooth functionality through operating system settings, but this approach proved impractical for users who depended on wireless peripherals for essential accessibility functions, medical device connectivity, or vehicle operation. Some organizations attempted to deploy localized jamming systems operating in the 2.4 GHz band to suppress all Bluetooth communication within their facilities, but these systems also disrupted Wi-Fi networks operating on overlapping frequency channels and triggered automatic interference detection mechanisms in cellular base stations serving the affected areas. Device manufacturers with the capability to push firmware updates to their products initiated emergency development of patches intended to restore proper pairing authentication, but the standard Bluetooth update mechanisms themselves relied on establishing trusted connections to perform the firmware transfer, creating a circular dependency where the devices most severely affected by the pairing dysfunction were the least capable of receiving corrective updates. Analysis of the affected device population indicated that the dysfunction was not uniformly distributed across all Bluetooth implementations. Devices running Bluetooth Stack version 5.2 and 5.3 showed significantly higher rates of abnormal pairing behavior compared to devices on version 5.0 and 5.1, suggesting that the root cause involved specific optimizations or feature additions introduced in more recent protocol revisions rather than a fundamental flaw in the core specification architecture. Between 13 and 1600, the failure pattern propagated into transportation systems and public infrastructure where Bluetooth connectivity had been integrated for fare collection, access control, and real-time tracking applications across the Bay Area transit network. Contactless payment terminals at Caltrain stations registered multiple simultaneous card authentications from passing passengers, processing duplicate transactions before back-end fraud detection systems could identify and block the erroneous charges. Electronic door locks in office buildings and residential complexes using Bluetooth Low Energy for proximity-based access control began responding to authentication credentials from any compatible device within signal range, not just the specifically enrolled smartphones and key fobs intended to control those locks, creating significant physical security vulnerabilities that required immediate reversion to mechanical key systems or manual security staffing. Vehicle-to-infrastructure communication systems designed to support traffic signal priority for emergency vehicles and transit buses experienced severe degradation as the increased Bluetooth advertisement traffic consumed processing capacity on roadside equipment that was not dimensioned to handle the substantially elevated packet rates. The San Jose International Airport suspended use of its Bluetooth-based indoor positioning system that assisted passengers in navigating terminal facilities after the system began generating location estimates that placed individual users simultaneously in multiple terminal locations due to the cross-contamination of device identity signals. These infrastructure impacts illustrated a largely unexamined dependency relationship where critical operational systems had been designed with the implicit assumption that Bluetooth device pairing would function as a reliable authentication boundary, an assumption that proved invalid under the specific failure conditions manifesting throughout the region. Forensic examination of affected devices conducted during the afternoon hours by engineering teams at Qualcomm, Broadcom, and Nordic Semiconductor, the three primary manufacturers of Bluetooth radio chipsets used across the consumer electronics industry, identified evidence pointing toward a common cause related to an automatic security update distributed to Bluetooth firmware implementations during the previous 48-hour period. This update, designated as Bluetooth Core Specification Errata 14729, had been issued by the Bluetooth SIG to address a theoretical vulnerability in the pairing key generation process that could potentially allow cryptographic key recovery under specific laboratory conditions requiring precise timing measurements and physical access to device antennas. The errata implementation involved modifications to the random number generation routines used during the pairing handshake, specifically adjusting the entropy pool initialization to incorporate additional hardware timing variations intended to make key recovery attacks computationally infeasible. However, the updated random number generation code contained a logical error in its boundary condition checking that could cause the entropy pool to enter a depleted state under high-frequency pairing attempt scenarios, and when this depletion occurred, the pairing security validation routines would fall back to a deterministic mode that accepted any pairing request without cryptographic verification. The chipset manufacturers confirmed that their respective firmware builds had integrated errata 14729 between March 10 and March 12 using over-the-air update mechanisms that pushed the modified firmware to devices during low-power idle periods without requiring explicit user authorization, and that the problematic code path would only activate after the device had processed approximately 200 to 300 pairing attempts within a 24-hour window, a threshold rarely reached under normal usage patterns, but easily exceeded in the device-dense environment of Silicon Valley during typical workday conditions. Remediation efforts accelerated after 1600 as device manufacturers and operating system developers coordinated on a multi-layered response strategy that included emergency firmware updates, operating system patches, and temporary protocol parameter modifications to be distributed through existing software update channels. Apple released iOS 18.4.1 and macOS 14.4.1 at 1723 Pacific Time, containing kernel-level modifications that disabled automatic Bluetooth pairing acceptance and required explicit user confirmation for all new device connections, regardless of pairing history. These updates reached approximately 68% of active devices in the affected region within 4 hours of release through the company's established automatic update infrastructure. Google deployed a similar mitigation through Google Play Services version 24.12.15, which could update Bluetooth behavior on Android devices without requiring full operating system updates, achieving approximately 52% coverage within 6 hours. Chipset manufacturers issued emergency firmware revisions that implemented immediate temporary workarounds by disabling the problematic entropy pool optimization from errata 14729 and reverting to the previous random number generation implementation, accepting the theoretical cryptographic weakness as preferable to the demonstrated operational failure. However, these firmware updates required user-initiated installation processes for most consumer devices and achieved substantially lower deployment rates than the operating system updates. By 2200, monitoring systems indicated that new pairing anomaly reports had declined by approximately 73% compared to peak incident rates, though significant numbers of devices remained in affected states due to the fragmented nature of device ownership and update installation patterns across the consumer electronics ecosystem. Post-incident analysis conducted over the subsequent week examined 847 gigabytes of device logs, network packet captures, and spectrum analyzer recordings collected from 1,247 separate monitoring points across the affected region, assembling a comprehensive timeline of the failure propagation and documenting the specific technical conditions that enabled a routine security update to produce such widespread operational impact. The Bluetooth Special Interest Group initiated a formal investigation into its errata review and distribution processes, specifically examining why the random number generation code modifications had not been subjected to stress testing under high device density scenarios that might have revealed the boundary condition error before widespread deployment. Preliminary findings indicated that the standard protocol conformance test suites used to validate Bluetooth implementations focused primarily on correct behavior under normal operating conditions with small numbers of devices, and did not include test cases simulating the rapid successive pairing attempts that could trigger entropy pool depletion. The incident also prompted review of the assumptions underlying automatic firmware update mechanisms that allowed security patches to be deployed to hundreds of millions of devices without staged rollout procedures or enhanced monitoring for unexpected behavioral changes. Internal documentation from multiple device manufacturers acknowledged that the wireless connectivity market's competitive pressure for rapid security response had created incentives to minimize the delay between vulnerability disclosure and patch distribution, potentially at the expense of adequate verification testing. The technical failure exposed a structural characteristic of modern wireless protocol implementation, where the benefits of ubiquitous connectivity and automatic security maintenance carried inherent risks of synchronized failure modes that could affect entire geographic regions when common components contained identical defects, and where the distributed ownership of affected devices created fundamental limits on centralized remediation capabilities regardless of the resources available to responding organizations.